So here we are now going to start single layer perceptron network. Till now what we have done was we have taken a neuron and then it was being updated, its weights were being updated using our delta W rules, 7-8 rules that we have seen. Now we are trying to have a single layer like this, and this layer will be trained for some job. Okay, there are so many neurons here, say maybe 1 to k, and I want to learn, suppose if it is a classification problem, I want to learn classes, say number of classes equal to, let us say, k. Now before I do that, we will see this basics, how these things were evolved, how this, say, let us say neural network kind of thing evolved, and what were the earlier approaches so that the same job was done in those days, and why the neural network came into picture. Okay, so we will go through this quickly. Now you see a diagram here with the title discriminant functions. Okay, so what is basic idea? Here I have input. This is input feature vector. This is input feature vector x consisting of some features like x1, x2 up to xn as usual. Now this feature is supplied to the functions g1 to gk. Now this g1x, this g2x and gkx, they are responsible for different classes. Say g1x is responsible for class 1. Suppose there are 10 classes and this g1x is responsible for, say, number 0. This g2x is responsible for number 1, and maybe this g10x is responsible for digit 9. So what is expected if you supply here feature of, let us say, 1, so this is applied here, then this function g2x, which is responsible for, say, digit 1, will produce maximum response. Okay, and the other nodes, say this one, maybe some others here, they will produce less than this node. So winner class index is supplied as output. So winner class index is here 2, then I will say the input belongs to class 2. Now suppose I apply here digit 9, then you expect that this g10x will produce maximum response, and you will declare its index 10 as the category. So what is the idea? For each class, we will design one separate function. Okay, suppose I want to learn 100 classes, then I will have to design, say, g1 to g100. So many functions, each responsible for one category. What is job of that function? Whenever input is from that category, it will produce largest response. Now how we can do this? So let us try to do for a 2-class problem. So this is a typical two-class problem, which is easy to understand. Now you are being supplied here 6 samples. The 3 belongs to class 1 and 3 belongs to class 2. So you can draw like this, and say this is x1, maybe this is x2. Then you can plot these points, say 0, 0, minus 0.5. So this is done. This is minus 0.5 minus 1. So this is, say, minus 1, minus 2, plus 1, plus 2. So this is minus 0.5 and minus 1. Somewhere I think here. The next one is minus 1 and minus 2. Somewhere here. So these are class 1 samples. Then you have 2, 0. So maybe this is 2, 0. And then 1.5 minus 1. Then 1 minus 2. Okay. Now what is our job here is to classify these samples. These are called as training samples. From this you want to learn how is class 1 and how is class 2, or where is class 1 in the x1 x2 space and where is class 2 in this space. So whenever I supply you new sample, let us say 3, 4, can you tell me what is class of this? Okay, so this is our task. Now here what we want to do is we want to design a structure like this. So this will be my input. Since this is a 2-class problem, so I want to design g1x, a discriminant function. Discriminant means the function which can separate or discriminate between classes. So this is g2x. Now this will go to a max selector. And index of this will be your output, maybe 1 or 2. So we want to design this g1x and g2x. Now see this diagram. Here I have drawn a line like this. So this is the line called as decision surface or decision line. This side of the line is, I think, class 2, and this side of the line is class 1. So what I have done is I have taken these samples into account. Okay, I have taken these samples into account, and I just draw this line which separates these samples into 2 groups. Say this side is class 1, so there is no mixture of other samples. Suppose I draw a line like this. What will happen? This side of the line consists of 1 sample of class 1 and 1 sample of class 2. So this is a bad kind of division, and you can see above this line 2 samples are from class 1 and 2 samples are from class 2. Then somebody say, okay, I will draw like this. Is this fine? Then I will say, okay, this is better than the earlier one, but still this sample is declared as class 2 since this side is majority class 2 and this is a wrong thing. This is a wrong sample this side. So like that, if you keep on doing, then best line which is doing the job correctly is here, this black one. So this black line is doing separation correctly, that this side is class 1 and this side is class 2. Now, if you take these intersection points, which we have decided, so this line is decided by us. Okay. So somebody may say, okay, sir, I don't want this line, I can take this line. So this is also perfectly fine. So there is no problem or no harm in choosing this line. So this is also perfect. So ideally, how many solutions you can have for such kind of a problem? So you can have infinite solutions. So from this to this sector, you can draw any line, and theoretically I can draw infinite lines. So you can have infinite solutions to the given problem. But let us say I have selected this line and this has intersection here and here. So based on this, you can easily find out this line equation. Now our task is to find out G1x and G2x. Okay, if I do this, then there will be a function responsible for class 1, that means this region, and there will be a function responsible for class 2, so this region. So I want two functions. G2x will be responsible for this particular zone and G1x will be responsible for this particular zone. Okay. Now to do that, to design these two functions, we are going to take help of the coefficients of the line. Okay. Now how I can do that? If you closely monitor or observe the coefficients of this particular line. So what is this line? This is minus 2x1. This is minus 2x1 plus x2 plus 2 equal to 0. So this is my line here. Now if you take the coefficients of the variables, say this one, and here it is 1. So this is minus 2 and 1. So if you take the coefficients of the line, this is minus 2. So if you plot this minus 2, where is this? Minus 2 is here and 1 somewhere here. So if you draw this particular vector, this will be perfectly perpendicular to this line. Okay. So this is always true. Even we can prove that. So this is always perpendicular. This vector is always perpendicular to a given line. Now if you multiply this line equation by minus 1, what will happen? So this will be plus 2x1 minus x2 minus 2 equal to 0. So I am multiplying this equation by minus 1. So if I collect now coefficients of this line, with coefficient of variables of this line, so it is 2, now minus 1. So where is this? This is 2 and minus 1 somewhere here. So this is also perfectly perpendicular to this line. So these are two pairs actually. These two vectors are opposite direction vectors. So if I draw vertically, so this is 2 minus 1 and minus 2 1. Okay, so these are two vectors which are actually perpendicular to the line. I can draw neatly here, suppose like this. So this is 2 minus 1 and this is minus 2, I think 1. Okay. So these are two vectors which are now perpendicular. Now what we are going to do to find G1x and G2x. Now listen carefully what I am trying to do. I will lift this vector. Okay, if you can imagine in 3D way, I am going to lift this vector like this by some degree. Okay, this vector is suppose lifted like this. Then I am going to lift this vector by some amount like this. So if you see from this side, say if you are standing here and if you see from this line, then I'm going to do like this. This will be your actual line, and these are the original positions of the vectors which are perpendicular to this line. I'm going to lift this vector by some amount. I'm going to lift this vector by some same amount. So this will be fixed. Suppose I'm lifting it by 2 unit, I will lift this also by 2 unit. Now next step that I'm going to do is I'm going to pass certain plane which is perpendicular to this vector and this vector. Can you imagine that? So I may be passing some plane, maybe somewhere here, say let us say perpendicular to this vector and perpendicular to this vector. Okay, so I hope you can imagine this. So what is procedure? This is our decision line, this one. Then I find out two vectors which are perpendicular to this line, which are here. Then I lift these vectors by a certain amount like this, and then I'm going to pass two planes which are say perpendicular to these two vectors. Okay, say a plane which is perpendicular to this and a plane which is perpendicular to this. And these functions or these planes, I am going to call it as G1x and I am going to call this as G2x. So what is happening here is you can just see that, say this is plane number 1 and there will be another plane here like this, and this will be your actual decision line. So I may call this as G1x, I will call this as G2x. Now what happens if you supply some input here, say X test, for this particular input this will be value of G2x. Okay, say G2x, I can say test, and for G1x you can extend this plane like this. You have this much value. So this much value is for Gx test 1. Okay, I can write here instead of writing here, I can write here. So which one is bigger? G2x is greater than G1x. Why? Because this will produce only this much and this will produce this value. So this value is greater than this value. So my function G2x is more than G1x. Then I can say input X test belongs to class 2. Now suppose I take some sample which is here. Your G1x will produce this much value and say G2x will produce only this much. Okay, so in that case G1x is greater than G2x. Okay, G1x is greater than G2x, then I will say okay, this X test belongs to class 1. So this is the idea. Still our design is not complete. We have to find out values of G1x and G2x. I have to find out these functions. Now to do that, we need to know these basic equations called as two-point form. So two-point form is used to find out that line equation, which you can note down these things. So this line I can draw as per my wish. Suppose I am drawing this black line, then I have intersection here and I have intersection here. So this is 1, 0, and the second point is 0, -2. So I take these two things, 1, 0 and 0, -2, and use two-point form to find out the line equation. So you can just substitute their basic values of x and y, x1, y1 and x2, y2, and you will easily find out this equation. Now the normal vectors that I was talking about, then you will collect the coefficients. So this is a generalized example. You can just use it for any other data. You can take this -2, +1, and opposite of that, that is +2 and -1. So they will be your normal vectors. So remember, here we got two normal vectors for our line. Then, as I said, I am interested in obtaining these two planes. One of them I am calling it as G1x, other one is G2x, and actual my line is passing like this. Okay, and this is actually the plane intersection. So line is lying over x1, x2 plane. So this is x1, x2 plane. You can see that this line is maybe lying somewhere down here. I can draw, I think, maybe somewhere here. I hope you can imagine that. So this is lying over this plane, and these two things are above that particular x1, x2 plane. So this is third axis. Maybe line is like this. Okay, and above that line, we want to design these two planes. Okay, now how to do that? As I said, we will take this vector which is normal to our line, decision line. Okay, this is normal to the decision line. Then this vector is suppose 2, -1. So I am taking this vector as 2, -1, and we are suffixing 0 here, so that we are adding now third axis. So this is now third axis called as G1x. Now I will lift this vector by some amount 2. So this vector is 0, 0, 2. So this is getting added with 2, -1, 0. So you know the vector addition. So this will be the resultant vector 2, -1, 2. Okay, this is 2, -1, 2, which is the resultant vector. Remember, this is my decision line. I am looking from top now. So this is same decision line on x1, x2 plane. This is a normal vector to the decision line. So this is a normal vector to the decision line. This is being lifted by amount 0, 0, 2. And the resultant vector is this one. Similarly, I can lift the other vector and I can get another, say, lifted vector like this. Okay, which will be -2, +1 and 2, because I am lifting it by same amount. Now I have two vectors, 2, -1, 2, which is a lifted version of the normal vector, and this is -2 +1 2. Now we will normalize these two vectors. So first step is to normalize these two vectors so that I can use normal vector point form of a plane. What it means, if I supply you a normalized vector like this, okay, then you can easily find out plane equation which is perpendicular to this, provided you supply this point P. So if you supply point P and a normal vector for this point P, then you can easily find out this line equation using this equation. So what is this equation? It is R transpose, that is normalized normal vector. These are your space variables, and xp is the point through which you want that this plane will pass. Okay, so you have to supply point P and normal vector. Okay, then you can easily do this. Now here we have two vectors, say this one and this one. Let us first of all normalize this. So what you do is you just take length of this. So this is 2 square plus -1 square plus 2 square, square root of that. Then multiply with this vector 2 -1 2. So this will be 4 plus 1 plus 4, that is 9, and square root of that will be 3. And you divide it by 1 by 3, then you will get 2 by 3 minus 1 by 3 and 2 by 3. Similarly, you take the second one and do the normalization, you will get -2 by 3, 1 by 3, 2 by 3. So these are our normalized vectors. What is left now is to decide through which point these planes will pass. Okay, so I have decided, suppose here the point through which these planes will pass is 1 0 1. So this is done intentionally. So you can see here. So this is the point. This particular point is 1 0, and if I take this 3D space, so this will be 1 0 0. Now intentionally what we are doing is we are taking the point 1 0 1. So where is this? So this is 1 0, and I am taking it somewhere here. Okay, so this is the point 1 0 1. What I am saying now is I will pass one plane through this, okay, which will be perpendicular to this particular vector. So this vector is now known to us. This is the value, and I am using this vector, this point P, and I will pass one plane which is perpendicular to this. So you can see here, this is the way we can do it. So this is normalized vector 1, this is normalized vector 2. These are the space variables. I am just listing them, x1, x2 and g1, and this is the point xp, which is equal to 0. So this is for second one, same thing. Now if you substitute the proper values of normalized vector r1, r2, and arrange for this g1x and g2x. I can write here g1x and g2x and collect the other things on right hand side. So you will get two equations. So this is equation 1, this is equation 2. So g1x will be responsible here for class 1 and g2x will be responsible for class 2. Okay, so we can check for all training inputs whether this is giving you correct answer or not. Now remember that if you take intersection of these two lines, these two planes, you will get your decision boundary back, which you have decided at the beginning. So we will revise this problem again in next class. I just want to revise steps that I have done. Initially, I was supplied some samples on x1, x2 plane. Say there were samples, say here, there were samples here. Then suppose I have decided that this will be my decision boundary. Then I found out two normal vectors to this line, decision line, and these two normal vectors were lifted in 3D space like this, and two planes were passed through this. I will call this as G1x, and then I will call it as G2x. And we have obtained using normal point form these two functions. So the job left now with us is whether these two functions are really doing the classification job or not. So that we will see in next class. So before I start this again in next class, I urge you to go through this book of Zurada and try to read this. You may not get the things immediately, so you have to read basically from book, and I hope you will understand very easily. Okay, so let us stop here.